This is the supplementary video for lecture 10, where I will discuss the problems I wasn't able to discuss in class in exercise 6 and 7. So for exercise 6, Jenna actually asked me to show how to work out f double prime of x by the product rule, and because of time limit, I wasn't able to show the details in class. Now let me do it here. So if I want to do the product rule for f double prime of x, so that basically means I need to write f double prime of x as the derivative of 1 over 2 root of x e to the x prime plus the derivative of root of x e to x prime. From the product rule, I know that the derivative of the first guy will be the derivative of the first factor times the second factor plus the first factor times the derivative of the second factor. Okay, so I will skip the derivative of the second guy over here because it's precisely going to be this guy. So I will just copy them later. Now for the derivative of 1 over 2 root of x, it will be better if I rewrite it as 1 over 2 times x to the minus 1/2. So then the derivative of 1 over 2 times x to the minus 1/2, I can use my power rule to conclude that the derivative of this guy will be 1/2 times minus 1/2 x to the minus 3 over 2. Okay, so this can be further rewritten as minus 1 over 4 times 1 over x to the 3 over 2 power. So then sometimes it will be better to actually rewrite everything back in terms of the radical expression. So that way I will get minus 1 over 4 times 1 over root of x to the cube. But root of x cubed can be simplified as x root of x. All right, so that's the result I'm going to use for this guy over here. Now let's finish the problem. So then what I should get is 1 over 4 x root of x times e to the x. And then plus 1 over 2 root of x times e to the x. And finally, I need to copy these guys up here for my 3 dots over here. So that way I will get 1 over 2 root of x e to the x plus root of x e to the x. Okay, simplifying, what I will get will be minus e to the x, 4x root of x plus 1 over root of x e to the x. This is obtained by combining the middle two guys together. And finally, that will be root of x e to the x. Okay, so this is how we compute the f double prime of x using the product rule applied to over here. Now let's continue with the geometry problems. So one of the geometry problems is to find the equation of tangent line and normal line of the function y equals to 1 plus x divided by 1 over e to the x. So at this point 0, 1/2. Okay, so well, recall that the slope of tangent line is simply the derivative. So let's start by getting the derivative, dy over dx. So dy over dx is simply going to be the derivative of this quotient, and I need to use the quotient rules. In this supplementary video, I will try to be fast and skipping the intermediate steps over in the quotient rule. So by the quotient rule, what I get is going to be square low, so 1 plus ex squared. Then it will be low d high, and what's my d high over here? So it will be the derivative of 1 plus x, and my derivative of 1 plus x will be 1. And then minus high times d low. So high d low, what's my d low? Well, the derivative of 1 plus e to the x, that will simply be e to the x. All right, so this is what the quotient rule tells me, and I can further simplify this guy. So the numerator is simply 1 plus e to the x minus e to the x minus x e to the x. So the middle two guys will cancel out. So what remains will be the first guy and the fourth guy. So what remains is 1 minus x e to the x divided by square of 1 plus ex. All right, so that will be the derivative dy over dx. And now we are interested in the tangent line of the curve at the point x equals to 0. So that means we need to know the dy over dx when x equals to 0. So you plug in x equals to 0 over here, what you will get is 1 minus 0 divided by, I'm missing a square over here. So that will be 1 plus 1 square, and the answer will be 1 over 2 square. That will be 1 over 4. All right, so this will be the slope of tangent Okay, so knowing the slope of tangent so that we can know the slope of normal is simply going to be a negative of the reciprocal of the slope of tangent, and the answer will be -4. All right, so knowing these two slopes together with the point, so we can use the point slope formula to finish the equations. So the equation of tangent, so this will be y minus 1/2 equals to 1/4 times x minus 0. And the equation of normal, so this will be y minus 1/2 equals to -4 times x minus 0. So you could further simplify this guy as y equals to 1/4 x plus 1/2. And similarly, you can further simplify the normal line as x equals to -4x plus 1/2. Yeah, but these are not absolutely necessary. So yeah, I think the point slope formula we leave over here will be perfectly fine as the final answer over here. Okay, so this will be the solution to this geometry problem. And for the next one, the situation is similar. So all you need to do is to compute dy over dx. So then repeat this whole process similarly. So dy over dx in this case will be so square low, that will be x squared plus 1 squared. And then that will be low times the high. Well, the high in this case will be 2. And then minus high times the low. Well, the low in this case will be the derivative of x squared plus 1, and x squared plus 1 has got a derivative 2x. All right, so simplifying the numerator, let's see what we get. So that will be 2x squared plus 2 minus 4x squared, and that will be 2 minus 2x squared. So that's what I will get for the numerator. So that's going to be 2 minus 2x squared divided by x squared plus 1 squared. So if x, now because we are interested in the slope of the tangent at x equals to 1, so over here. So then when x equals to 1, what I have, it will be 2 minus 2 times 1 squared divided by x squared, 1 squared plus 1. And then take the square, but the numerator being 0, so the whole thing is going to be equals to 0. Okay, so this tells me that my slope of tangent is 0. So now the question is, what is the normal line? Okay, so but if you blindly use the slope of normal, and then that means you need to take the negative of reciprocal 1 over 0, but this guy does not really make sense. So what exactly is going on here? So notice over here, what we have is indeed a horizontal line because the slope of tangent equals to 0. So at the very least, I can actually write that my equation of tangent, so this is going to be y minus 1 equals to 0 times x minus 1. So this will simplify as y equals to 1. So this is actually like a horizontal. So this is a horizontal tangent. Okay, so when the tangent line is horizontal, what does that mean to the curve? Okay, let's just draw a picture to understand what's going on. So the tangent is horizontal, so it means the tangent looks like this. And remember one thing, that a normal line is precisely the line that's perpendicular to the tangent line. Okay, so if the tangent line is horizontal, what does it tell us for the normal line? Well, it simply tells us that the normal line will be vertical. So that's basically why the slope does not make sense, because for a vertical line, well, the vertical line is represented by x equals to something. So, and then, well, for vertical line, the slope is undefined over here. All right, so that's basically what we can know. So because we have got a horizontal tangent, and then this will actually tell me that equation of normal is simply going to be x equals to 1. So where the 1 over here comes from here. All right, so that will be the answer to this problem. So for this problem, y equals to 1 will be the equation of tangent, and x equals 1 will be the equation of normal. Now let's look at number 54. So we need to find the equation of the tangent lines to the curve y equals to x minus 1 divided by x plus 1 that are parallel to the line x minus 2y minus 2. Okay, so before working out the computations, let's just recall some conceptual points. So two lines that do not coincide are parallel if and only if their slopes are equal. So basically speaking, we need to find out where the tangent lines of this curve has the same slope to the line x minus 2y minus equals to 2. Okay, so then what's the slope of this guy? So here's the second conceptual point. So the slope of a line with equation ax plus by equals to c. So the slope of this line is the same as the slope of the line y equals to minus a over bx plus c over b. So this is the second equation is obtained by moving ax to the right, then divide both sides by 3. All right, so that's what I get. But then slope of this guy is simply going to be the coefficient of x. So that way we know that minus a over b will be the slope. So applying this knowledge to the line we have over here with a equals to 1 and b equals to minus 2. So we see that the slope will then be negative of 1 divided by minus 2, and the answer will be 1/2. Okay, so basically speaking, we are looking for points on the curve y equals to x minus 1 divided by x plus 1, where the slope of tangent, in other words, the derivative dy over dx equals to 1/2. Now let's start by computing dy over dx. Okay, so dy over dx is the derivative of the quotient x minus 1 divided by x plus 1, and let's just apply the quotient rule directly. So that will be square low, that will be x plus 1 square. And then on top, I have got low d high, and the derivative of high, it will simply be 1. And then minus high d low. So the derivative of low, namely the derivative of x plus 1, will still be 1. Okay, so the numerator can be simplified as x plus 1 minus x plus 1. So these two copies of x cancels out. So what remains will be 2. So as a result, the derivative will simply be 2 divided by x plus 1 squared. All right, so we need to set dy over dx equals to 1/2. So this will tell me that 2 divided by x plus 1 squared equals to 1/2. So this further tells me that x plus 1 squared equals to 4. Okay, so do not move this 4 to the left-hand side and perform something like the factorization. This is completely unnecessary. Indeed, what we have over here is sufficient for us to get the solution. So if we take the square root on both sides, what we will get is x plus 1 equals to plus minus root of 4, namely plus or minus 2. So in other words, either x equals to 2 minus 1, which is 1, or x equals to minus 2 minus 1, namely minus 3. All right, so these will be the two solutions of x. Okay, so we managed to find the x coordinates where the slope of a tangent equals to 1/2. But this is not what we are asked for. We are asked to find the equation of the tangent lines. So that means we also need to get the equations of the tangent lines when x equals to 1 and x equals to minus 3. So in order to find the equation of the lines, we also need the y coordinates. So if x equals to 1, then the y coordinate is computed using the formula x minus 1 divided by x plus 1. So my y coordinate will be 1 minus 1 divided by 1 plus 1. And the answer will be 0/2, which will be 0. Okay, so now we know the slope, and we also know the x coordinate and the y coordinate. So using the point slope formula, we will get the equation of tangent to be y minus 0 equals to 1/2 x minus 1. So this guy can be further simplified as y equals to 1/2 of x minus 1. All right, so this will be the equation of tangent when x equals to 1. All right, so the second one, when x equals to minus 3, so let's compute the y coordinate. So the y coordinate will be minus 3 minus 1 divided by minus 3 plus 1. So that will be minus 4 divided by minus 2, and the answer will be 2. So the equation of tangent when x equals to minus 3 will simply be y minus 2 equals to 1/2 times x minus negative 3. So let's further simplify it as y equals to 1/2 x plus, this will be plus 3 over 2 plus 2, that will be plus 7 over 2. Okay, if this were a test problem and you managed to get these two equations, then I believe you should get the full credits. Although mathematically, in the most rigorous sense, you also need to check that these two lines are not coinciding with this line over here. And then in order to check that, let's actually solve the equation from this here. So that this actually tells me that y is going to be equals to 1/2 times x minus 2. All right, so because for this guy over here, so if you plug in x equals to 0, you see that the y-intercept equals to minus 1, while the y-intercept for this guy will be minus 1/2, and the y-intercept for this guy will be 7 over 2. So these two guys, these three guys are not the same. So that way you can fully confirm that the line you have obtained over here are really parallel and not coinciding with the line x minus 2y equals to 2. Okay, so for the mathematical rigor, I will just add the following comment that both lines are parallel to, and which means not coinciding with x minus 2y equals to 1. All right, so that will be a completely rigorous solution to number 54. Okay, let's now work on number 46. So if h of 2 and h prime of 2 are known, we need to find out the derivative of this fraction at the number 2. Well, this is a very easy application of the quotient rule. So d over dx applied to h of x divided by x by the quotient rule, that will be square low and then low d high minus high d low, and d low in this case is going to be 1. All right, so this is what we get. So if x equals to 2, so then this will imply that the guy we are looking for as x equals to 2, so this will be 2 times h prime of 2 minus h of 2 times 1, and I will skip that, and divided by 2 squared. All right, so h prime of 2 equals to minus 3, so all I get is 2 times minus 3. And h of 2 equals to 4, so that's what I get. And downstairs, I get 2 squared, which is going to be 4. So that will be minus 6 minus 4 on top, that will be minus 10. And minus 10 divided by 4, that will be minus 5 over 2. All right, so that will be the solution to number 46. Okay, last problem in exercise 6. So if f is a differentiable function, we need to find an expression for the derivative of each of the following functions. And I think it's necessary to add up the descriptions in terms of x and f of x. All right, so this is just another application of the differential rules, and then you just need to use the rules appropriately to get the answer. Okay, let's look at part A. This is just a very simple application of product rule. So dy over dx, which is simply going to be the derivative of x squared times f of x. And by the product rule, what I get is going to be 2x times f of x plus x squared times f prime of x. Okay, so that will be the expression we are looking for. For part B, so this will be a simple application of quotient rule. So what I will get is the derivative of f of x over x squared. Well, just remember what the quotient rule tells me. So that will be square low, and then so low d high minus high d low, and d low in this case will be 2x. Okay, simplify a little bit. So notice that the bottom denominator over here is precisely x to the fourth power. So then there will be a common factor x everywhere. So then after canceling out the common factor, what you will get is x f prime of x minus 2f of x divided by x cubed. And that will be the solution to part B. So part C is precisely the reciprocal of the function in part B, but then we just follow the rules over here. So we first square low, then low d high. Well, the derivative of x squared, that will be 2x minus high d low. Okay, so that's what we are getting at. So I don't think there's any further way to simplify this. Let's just leave the solution like this. Okay, so for part D, yeah, you could certainly try to use quotient rule for this guy, and I will leave it to you to carry out the computations. What I will do is going to be slightly cleverer. So I will just rewrite the function as y equals to 1 over root of x plus x f of x divided by root of x. And this guy can be simplified as 1 over root of x plus root of x times f of x. So if I write this function in such a form, then it will be easier for me to carry out the computations afterwards. So the derivative of 1 over root of x, so that will simply be the derivative of x to the minus 1/2. Let me just keep it over here and evaluate it later. And the derivative of root of x times f of x, so I can use the product rule for this guy. So that way I will get 1 over 2 root of x times f of x plus root of x times f prime of x. Okay, so this is the expression I get. And then using the power rule, we could see that the derivative of x to the minus 1/2 power, that will be minus 1/2 x to the minus 3 over 2. Plus 1 over 2 root of x f of x, and then plus root of x f prime of x. So certainly you could actually further simplify this guy as minus 1 over 2 x root of x. Certainly you could do that, but it's not necessary. So this is a satisfactory answer. All right, so I will leave it to you to figure out how to do this using quotient rule, and you will find the solution will be much more complicated. We will conclude this supplementary video by the 3 geometric problems in exercise 7. So the rest of the exercise 7 problems will be discussed next Tuesday. So for 22, we need to find an equation of the tangent line of the curve y equals to e to the x cosine x at 0, 1. Well, the drill will be the same. You take the derivative of this guy and you evaluate it at the point 0 to get the slope of the tangent. Then you use the point slope formula to get the equation of the tangent line. So now let's carry out the process. So dy over dx will be the derivative of e to the x times cosine x plus e to the x times the derivative of cosine of x. Well, simplifying, I get e to the x cosine x minus e to the x sine of x. So if x equals to 0, so that what I get is e to the 0 cosine of 0 minus e to the 0 times sine of 0. So e to the 0 equals to 1, cosine of 0 equals to 1, e to the 0 equals to 1, sine of 0 equals to 0. So at the end of the day, what I get is 1, and this will be the slope of tangent. Therefore, the equation of the tangent will be y minus 1 equals to 1 times x minus 0. So, or you could simplify it as y equals to x plus 1. All right, so this will be number 22. Okay, similarly, we handle number 24. So dy over dx, in this case, I need to take the derivative of x plus 10x. Well, derivative of x equals to 1, derivative of 10x equals to secant squared. So when x equals to pi, what I get is 1 plus secant squared pi, but I don't know very well what secant pi is. So that's why I need to write it in terms of cosine, and I'm supposed to know very well what cosine of pi is. So cosine of pi equals to minus 1. So it will be 1 plus 1 divided by minus 1 squared, and the answer will be 2. Okay, so that will be the slope of tangent. Therefore, the equation of tangent we are looking for, so this will simply be y minus pi equals to 2 times x minus pi. So you could further simplify it as y equals to 2x minus pi, but this is not necessary. You do not need to do that. Okay, finally, for problem 34, we need to find out the values of x where the graph of this function have a horizontal tangent. So this basically means we need to first evaluate the derivative, then figure out where the derivative equals to 0. So that's what we are supposed to do. Okay, we have seen the derivative of e to the x cosine of x in the previous problem, namely 22. So what I get is precisely e to the x cosine x minus e to the x sine of x. Okay, and I need to set this guy equals to 0. So dy over dx equals to 0 implies e to the x cosine of x equals to e to the x sine of x. Okay, so this will tell me the following. So first, e to the x is never 0, so I can divide by e to the x both sides to cancel out this factor. So what remains is cosine of x equals to sine of x. Okay, how do we solve this? So the most straightforward way to solve this is to use the unit circle. So remember, for a given point on the unit circle, so the x coordinate is the cosine of x, and the y coordinate will be sine of x. Okay, cosine of x equals sine of x. That means, well, the x coordinate and the y coordinate has to be the same. Only 2 points on the unit circle will satisfy this condition, and namely the point corresponding to pi over 4, and the other point is corresponding to 5 pi over 4. Okay, but just be a little bit careful. So this does not necessarily mean you only have got 2 solutions. You need to keep in mind that the both cosine x and sine x, they are periodic functions. So this basically tells me that x can take 2k pi plus pi over 4, or x equals to 2k pi plus 5 pi over 4. So that will be the solutions. Okay, so you could actually rewrite it as x equals to k pi plus pi over 4, because this guy over here, you can actually write it as pi plus pi over 4. So basically speaking, what I get over here will be the odd multiples of pi plus pi over 4, then together with the even multiples of pi plus pi over 4. So I can actually rewrite the solutions like this. So this formula will be covering both these guys over here. And here, certainly I need to require that k equals to 0 plus or minus 1 plus or minus 2, and etc. All right, so this will be my answer. So for these values of x, the graph of f of x equals to e to the x cosine x will have a horizontal tangent. So this will be the most straightforward way for you to solve this. So alternatively, so from cosine of x equals to sine of x, so you could probably get a tangent of x equals to 1. And then you could also get the same conclusion that x equals to k pi plus pi over 4, as k ranges over all integers. However, in order to conclude this part, so namely conclude the first right arrow over here, you've got to be a little bit careful. You need to make sure dividing by cosine of x on both sides does not lose any solution. So this basically means you need to argue that if cosine of x equals to 0, then sine of x is non-zero. Okay, so this will tell me that I will be allowed, I can divide cosine of x on both sides without losing any solutions. Okay, and this fact is pretty easy to argue, because cosine of x equals to 0, that means x has to equals to k pi plus pi over 2. But then in this case, you could track that sine of x is either positive 1 or negative 1. So this part is certainly fine. So that way you can divide on both sides without losing any solutions to conclude 10x equals 1. Then you use the graph of tangent of x. So 10x equals to 1. That means x can take these values over here, and you read the x coordinates, you see that this is precisely pi over 4. and this will pi plus pi over 4, and then all the rest will simply be k pi plus pi over 4. So that will be the rigorous argument for this one. Okay, I don't think we will be demanding that much. Even if you start from cosine x equals to sine of x, you conclude that tan x equals to 1 without writing this part, I don't think you will get any points deducted because of that. I think you will get full credits for this problem if this were a test problem. All right, so that concludes this supplementary video. And for the rest of the exercise 7, I will cover them in class.